Hey, last time I was here, I actually tried kicking on the some hair sticking out. Tried kicking on the air conditioner on my inverter, and it wouldn't do it. It kept tripping the inverter. So um, I've been wanting to throw a hard start capacitor on it, on the air conditioner that is, and see if that solves the problem. So, all right, guys, got a few things here. Um, Brought some silicone. Um, there's not a lot of places to mount these things. This capacitor does come with a small clip. You can kind of see it there. That's not very sufficient for a vehicle that's moving around. It might work for a home air conditioner. Also threw in a couple zip ties. They didn't come with it, but figured I might need them to secure it, especially while the silicone dries. This is Supco. I've had problems with pronouncing things. Supco, I guess. SPP6. So hard start relay and hard start capacitor. All right, here's the AC unit. We're up on the trailer. Manufacturer tells me it's a Coleman Mach 15. It just says Coleman Mach on the front here. If there's a label or anything on the inside, I'll go ahead and show that. But I had the manufacturer StarCraft look up my trailer based on the serial number, and they told me I had a 1500 BTU Coleman Mach 15. So I'm gonna go ahead and take these 4 screws off on top, and we'll take a look inside. All right, I'm gonna pull this panel off here and see what's inside. All right, so trying to see what you guys see. Okay, the big cylinder back there is the current, I guess it's the run or start capacitor, but that's where people have been hooking up. It's the run capacitor. Yep. Looking at the diagram here, so you can see this is the run capacitor. There's red and a yellow, and also a white hooked up to the yellow side. Can verify that right here. See, hard for you guys to see, but I can definitely see that there's the white. Yeah, there we go. There's the white going into the yellow side, the red on the runs, or on the red, the red going on the other side. So we've got an easy setup here, right? The start capacitor is a dotted line. I believe that implies that it's optional. All right. So as we mentioned, people were hooking it up. Relay side is the side of the wire with this. Again, this is the SPP6 from Supco Super Boost relay and hard start capacitor. Increases compressor torque 500%. The original. All right, brilliant, man. So one thing I do want to do is I was trying to fire this up about a week ago. I don't trust that capacitor, so I'm just going to go ahead and short across it. If you see me jump, Alright, so no power in that capacitor. I can feel semi-safe. Let's see if I can do this one-handed. Probably not. I'm left-handed for anyone who cares. So what I am going to do before I put this in, I'm going to fold up this extra spade. I just don't want anything grounding out on it. Just like that. side is on. And the other side is on. Not a ton of room in here, but definitely enough to get it in there. I don't think I'm going to have to use the wire ties unless I want to wire tie it around this other capacitor. But what I'll probably do is just load up a good clunk of silicone in there and call it good. But let's go ahead and crank this over, see if it works. So this is my main 30 amp. That has to be on. I don't want anything else on. I don't want, you know, my cradle point powering up or my Apple TV powering up or anything else like that. So I'm just going to flip on the AC unit breaker, which I'm 99% sure is this guy here. Let me turn on my inverter. All right, inverter is on. I haven't mounted that yet, by the way. Oh, there we go. All right, let me shut the other ones off. All right, so you can see, move my soda here. You can see the inverter is putting out 117 volts. It's nice and steady. Polarity. So I'm going to go ahead and turn that breaker off, so I'm not using any additional power for the AC. And let's come in and kick this on. So the first thing that's going to come on is the fan. I'm going to go ahead and power that up just so that motor gets up and running, doesn't surge. And now I'll turn it over to cool. I didn't trip the breaker, did I? Looks like I did. Not the breaker, but the inverter. Let's see if it's still. Okay, it just came back on. So realize here I'm trying this with a 2,000 watt inverter, and like I said, I believe at one point I had it working. So because the compressor tried to start, there was a start delay on it, and we'll see what happens here in a second. Doesn't feel exceptionally cold. Back to 85. The switch is on. Seemed like last time it took a little while for the compressor to reset or for the time delay. And there we go. It cut out. Here's my dilemma. The 2,000 watt generators are, so I switched off the AC. 2,000 watt generators are known to be able to kick over the 1,350 BTU ACs. I've got a 1,500 BTU AC, and I don't think 2,000 watts is quite enough to be able to run that. So the next step is to get my generator out. Alright. So with eco mode turned off, the compressor just kicked on, and my 3700 watt. Who makes it? Bolly, B-O-L-I-Y or something like that. My 3700 watt generator cost me about $1,000. It's remote start. We'll give that a try in here in a second because I didn't have any of these at home when I was working on it. Comes with two. They look like little remotes from 1983. You lose them. They're wood camouflage. Now the fan is on auto, so we'll see if the generator, because I don't like the fan running all the time. Fans are noisy. I actually need to put it on the low setting. That might be worth a try too if I really want to pursue this this inverter thing. Is just wire in the fan low side. But I think what I want to do is go back up on the roof and I don't know. I'm wondering if that capacitor is actually helping or hurting the situation. I guess it can't hurt. So I turn the AC back on, and as soon as we hear the fan come on and the generator ramp up, I'm going to show you guys the voltage here. Voltage. The fan needs to be on for that generator. Such a shame. I can't believe a 3700 watt, even if that's slightly overrated, even if that's max. I can't believe. Oh, I need to go restart the generator. Light's still blinking. There we go. Stop blinking. Alright, AC fan is on. And compressor's on. I don't think it's kicked on yet, but I don't know, it feels pretty cold, huh? Maybe it is running. Yeah, it's nice and cold. The generator, the crappy 3700 watt Bolly generator, it's running it. It's running the AC. Of course, the fan has to be turned on first, which basically means I got to keep that fan running all the time. So it's running it. That's the point, though. The 1200 watt inverter, I'm sorry, the 2000 watt inverter, it is not running it. Up on the roof and just, you know, sort of silicone everything in and leave that hard start capacitor in there. I can always pull the wires off down the road if I want to, you know, test things out or play around with it, but we're gonna go ahead and do that for now, see what happens. So should be more than good once that dries up. Man, I'd really hope this would work, but through this whole process, like I said, I learned that my AC is not 13,500 BTUs, but it's 15,000, which changes the game a little bit. 15,000 BTU AC is not a bad thing when it's 120 degrees out in Arizona. Alright, we're going to put that's closed back up. It's not going anywhere. We're not moving the trailer for probably a couple of months. So that'll have plenty of time to dry. I'm going to go ahead and put the shrouding back on. All right, we're back in business. That's pretty good. When the fan's already running, and I think a time delay on the fan would be great for any time we're trying to run the AC off the generator, and I can see that being, you know, something that we want to occasionally do for camping down here. So I may go ahead and order a time delay on the fan, because I really hate to keep that fan running all the time. It's like you just don't get a break from that noise. So I think I'll do two things. I'll put a high-low switch on there, and I'll also put a time delay switch on the thermostat, so that the compressor will have a chance to start up before the fan kicks in, lowering the overall spike that we get out of it, and that'll put a lot less stress on the generator. But you can see the fan was already running. Compressor kicked in, it dropped down, you know, 60s or 70s, somewhere around there, and then it's settled back down at 116, which is awesome. It's right about where you want it. So when the generator works, when devices are powering up in sort of the right order, it's doing great. As far as the hard start capacitor is concerned, I have no idea what the hell it's doing up there. As far as I know, it could be sucking in more power. Who knows? So. Hey, all right. So, kind of final thoughts on the whole generator inverter debacle. So, this is what I have. I've got this Bali Pro 3600. SIER Q-Blue RV Pro 3700 wireless remote start generator. That's a long title for a generator. So I've just been assuming that 3700 on the model number assumed you know, either a peak rating or a constant rating of 3700 watts, and wasn't sure which one. However, if we look here on the description, 75-pound dry weight, 3,000 watt rated, and a 3,300 watt output, maximum output. So, okay, has nothing to do with 3,600 or 3,700 in the title. Why do manufacturers do that? They must be smoking weed. They must just be liars. But if they're using a model number that in any way is close to a wattage rating, I think they're just being a little, I'll go ahead and say it, they're being a little unethical, I think. Either way, I didn't buy it under those conditions. I'm sure I looked at the fact that it was 30 amp rated. It is 3,000 watt, which is just below a 30 amp if you're measuring at 120 volts. So the point is this peaks at 3,300 watts maximum, and it'll sustain 3,000. So let's keep those numbers. A couple of key numbers we want to look at. So the compressor LRA and the compressor RLA. The compressor RLA is basically the amperage you can expect the compressor to pull while it's running. The compressor LRA is the amperage that you can expect the compressor to pull on start. Then we also have fan motor FLA, which is what you can expect your fan to pull while it's running. Change those numbers a little bit. But if I take 115 volts and I multiply it by 63 for my startup amps, I get 7,245. But now let's look at the running amps, and that's 12.9. So again, 12.9 times 115. So 12.9 times 115 is 1483. So in theory, my inverter could run this if it could get past starting up the motor. And I think what we're seeing here is that even with the hard start capacitor, my inverter is tripping before the motor gets started up. So too bad you can't get like a wheel on there that you could just spin, manually spin it to get it to start. It's a bad joke. So let me pull up the stats on my inverter and we'll take a look at those. Okay, so this isn't a spec sheet, but this is the inverter that I have. It's this Xantrex Pro 2000 inverter. As you can see, the power output is 1,800 watts, and it is a pure sine inverter. Doesn't say it here, but it definitely is. You can go to the manufacturer's site. You know, also if you go to the manufacturer's site, you'll see that it has a 3,000 watt peak rating. And so back to our label here, you can see that you know, the 1,483 watts to keep the air conditioner running. Since this pure sine Xantrex inverter can sustain 1,800 watts, is plenty to keep the air conditioner running. But once we go in and do the math on the 63 startup and the 3.4, that's 66.4 times 115, times 115 volts, and you know, 7,600. We're not even, with that inverter, we're not even coming close, right? And we're at 3,000 peak according to spec. So there's just no way that this inverter is going to start up that 1,500 BTU air conditioner. Was never expecting to. It's just a fun little thing to try. I was definitely hoping that the hard start capacitor would help. Maybe it would solve for the problem. I'm sure the hard start capacitor has changed the overall startup rating. 63 amps seems a little high to me in general. I find that a little hard to believe, but it's definitely not impossible, and it's probably a maximum rating for really kicking that on. You can look at the you know, maximum overcurrent amperage is 20, and that's for no electric heater. So still 20 amps. We're still looking at, you know, 20 times 115. Could probably do the math if I thought about it. It's 2,300, of course. You know, 2,300 is still outside of the normal operating rating of that inverter. So definitely mismatched from an inverter perspective. On the other hand, the generator is matched up pretty well. You know, the 63 amps, again, kind of find that a little interesting, but the the generator's able to struggle a little bit and get the compressor started, and once it seems to get it up and running, it stabilizes. And so I think that's what most people are finding out with their generators, is when they do kick on their AC, the generator does struggle a little bit. Takes a minute to, you know, bogs down some, drops down in voltage significantly, but within a second, two or three, recovers. And we were seeing that with the Bali 3700 generator, which is really 3000 watt continuous. We were seeing it bog down a little bit, but it seemed to really catch up within, you know, 2 or 3 seconds. It was back up, you know, over 100 volts, and stabilizing back at about 100, you know, 16 to 118 volts. So everything seems to be good with the generator. What can we say about this hard start capacitor? Well, I didn't do any tests up front, so I can't tell you anything. I can't really tell you if it's helped or if it hasn't helped. We may try disconnecting it down the road. At this point, I'll probably just leave it in place and use it as is. So that's my story, and I'm sticking to it. You guys have a good day. Enjoy.